Hey, and welcome. This one's gonna be pretty bad. All right, as far as toughness, as far as getting things, and we're gonna try and work slowly and methodically through this. Okay, I'll try. Here we go. So what we're going to be talking about is trigonometric identities. Identities are truths. They're facts. You don't have to prove them. That's a good thing. When I was in high school, we did. It was not pretty. But good news is you don't have to do that. Bad news is that you need to use algebra that you probably haven't used in a while. So here we go. Let's take a look. You're going to do some stuff with the identities. Here you have some identities. What I'm going to ask you to do is you have all these identities on one big giant sheet of paper. Please have that paper ready with you and working through these on the sides, not just the stuff that's inside the notes. Okay? So these are some we call reciprocal and quotient identities. These are things that I can substitute for. So instead of sine, I can say 1 over cosecant. Instead of saying tangent, I can say sine over cosine. That's a big one. You want to know that. Okay, the ones you want to know is that one, and then the other big ones are these right here. Okay, those are the ones I would know from here and get familiar with. These will all be available to you, but the more that you have memorized and know and are able to study with this, the better off that you will be. So what problems do I get from something like this? Now, first one that you would get is that they would tell you, hey, cosine of theta is equal to 3/4. What is secant of theta? So if I go up there and I take a look at the ones I just got done, the identities I just got done looking at, I can see that secant of theta is equal to 1 over cosine of theta. That means just the reciprocal of it. So if they give me what cosine of theta is, then secant of theta is equal to the reciprocal, or 4/3. But bam, done, easy. There it is. That will probably be the easiest one ever. All right, but it's the idea. So let's take a look at some more complex ones. It says here, if secant of x is equal to 5/4 and tangent of x is equal to 3/4, find sine of x. Holy cow. All right, so let's get some things that I may or may not know about here. So what I do know is, let's see here, that secant of x is equal to 1 over cosine of x. Okay. And I know that tangent of x, tangent of x is equal to sine of x over cosine of x. How is this helping? I begin to see a puzzle here brewing. Well, let's see here. Secant of x, I do know something about. Secant of x, I know it's 1 over cosine. So I can actually reverse that, right? Cosine is 1 over secant. So cosine of x in this case is going to be equal to, flip it, 4 over 5. Now, why did I do that? Because I want sine of x. I have it someplace in here, but I got to get rid of cosine of x. Here, I just found cosine of x right here. So, if I know what tangent of x is, I know what cosine of x is, I can set an equation up here. I can say that, hey, 3/4 is equal to, well, sine x, that's what I want, all over 4/5. Oh. Well, now that I have that, I can multiply both sides by 4/5. Okay, well, if I multiply both sides by 4/5, I have 4/5 times 3/4 is equal, well, when I multiply by 4/5, that goes away, and I'm left with sine x. Well, the 4's cancel, and I'm left with 3 over 5 is equal to sine x. Takes kind of a leap. You kind of have to know where you're going. This is not, not intuitive. It just takes practice with them. The more practice you get, the more intuitive you start seeing things, the more little tricks that you know in your book. Okay? For instance, this trick was, hey, I'm going to write things in sine and cosine and see if I can figure something out. And I kind of saw a puzzle with it. All right? So let's keep going and see what else I can find out. What else is out there? All right. So this one, you don't have answer choices with yours. This one does. So this one just gives you that secant of x is 13 over 5. What can I do to find sine? And this one is like, holy crud, they don't give me anything. But they do. Because remember, secant is really just, cosine is really the reciprocal of secant. So I can reciprocate that. So cosine is that. And you'll be like, great, I have cosine, but I want sine. How can I find that out? Well, next little trick up your sleeve is to make a triangle. Okay? So here I am. I'm going to make a triangle. I'm going to call this one up here. This is going to be my theta. Cosine SOHCAHTOA. Adjacent over hypotenuse. So here I'm going to make a right triangle. My adjacent's going to be 5. My hypotenuse is 13. I need to be able to go find this. Find this right here, right? Because of sine is opposite over hypotenuse. I need to find my opposite. Find my opposite. So a squared plus b squared equals c squared. 5 squared plus b squared, or in this case o, because that's my opposite, o squared, is equal to 13 squared. I'm going to cheat, use my calculator or my pattern that I know, and I know that o is going to equal 12. Therefore, when I take, what is sine opposite of hypotenuse? 12 over 13. I know you didn't have a whole lot of room, but hopefully that made sense. So 12 over 13, B is my answer. So there's another bag of tricks for you. Okay, if they don't give you a whole lot, let's go ahead and make a triangle. See what happens from there. All right, next one is Pythagorean identities. So this is where it gets a little bit more complicated. The biggest one here that we ask that you know is sine squared plus cosine squared is equal to 1. You also have here tangent squared theta plus 1 is equal to secant squared theta. Cotangent theta plus 1 is equal to cosecant squared theta. I'll be honest. I don't know this one, and I don't know this one. I only know this one. Okay? It's me being honest. Only know that first one. The other two will be there for you, but know that they exist. Know that there's a relationship with tangent squared and secant squared, cotangent and cosecant. Okay? So here we go. How can they make us do identities with this? Let's find out. It says cotangent theta is equal to 2 and cosine of theta is less than 0. Find sine and cosine of theta. All right. This is where we get a little bit creative. All right, so they're giving me some information. They want me to find sine and cosine. Well, I know there's a relationship with cotangent and cosecant. I know that cotangent theta squared plus 1 is equal to cosecant theta squared. So why do I want to know about that? Well, I know that cosecant is just a reciprocal of sine. So hey, if I find out what cosecant is, I can find out what sine is. And that's what I'm going to do. Well, I know what this here is 2 squared plus 1 is equal to cosecant theta squared. Well, 2 squared plus 1 is 5, so this becomes the square root of 5. Because I take the square root of both sides is equal to cosecant theta. But again, I don't want cosecant theta, I want sine theta. And I need to know that, cosecant theta, sine theta, is just 1 over cosecant theta. That's from the very top ones. Okay. And since I know that, well, then I know that the reciprocal, or just 1 over the square root of 5, is equal to sine theta. And actually, to be safe here, when I take the square root, what I forgot to do was put plus or minus. I don't know which one it is, because remember, when you take the square root, it could be the positive or the negative. I still don't know which one it is. until I take a look at what was cotangent. Cotangent was positive. And since cotangent of theta is equal to cosine of theta over sine of theta, and I know that cotangent was positive, but cosine is negative. So I know that this was positive equals negative over what? Well, if that's positive, negative divided by negative. So sine over here has got to be negative. So I do now know that sine is now equal to negative 1 over square root of 5. Well, then how can I find cosine? Well, here I have the same setup. I know everything. 2 is equal to cosine of theta over a negative 1 divided by square root of 5. Multiply both sides by negative 1 square roots of 5. Negative 1 divided by square root of 5. Times the negative 1 over, times the negative 1 over square root of 5. Becomes negative 2 over the square root of 5. Is equal to cosine of theta. And there it is. Woohoo. There's cosine. There's sine. Woo! Gotta take a break on that one. That was a lot. All right. Well, here's the deal. We're going to keep going. We're going to do at least one or two more, and we'll see what's going. So let's see what's next. All right. And here's what's next. All right. So it says find the value of cosecant and cotangent if tangent is equal to negative 4/3. Again, I didn't put the handy-dandy choices there for you, so we're just going to work this out. So what am I going to do? Well, one of these should be very straightforward, right? They're looking for a cotangent, and they give me tangent. So I should be able to look up there, and it says that, hey, cotangent of theta is equal to 1 over tangent of theta in those reciprocal identities. Oh, so what that means is that if I take the tangent, just flip it. Oh, okay. Well, so I'll flip it. So I know that cotangent of theta is equal to a negative 3/4. Done. Yay, that one's done. Okay. So shoot, already took away 2 answers. That was quick. That was easy. So one of the other things that we should take away from this is they give us another piece of information that cosine is less than theta. Or less than 0, excuse me. Cosine of theta is less than 0. Why is that important? Because cotangent of theta is also equal to cosine of theta over sine of theta. And if I know that cotangent is negative, so I know again cotangent is negative, and I know, and cosine is negative, what do I know about sine? Sine better be positive. So sine's got to be a positive number. Okay. All right. So that's good to know. So I should be able to find out what sine is maybe. Okay. So what else do I know? Let's take a look at those different things that are up there. Well, I might be able to figure out something about cotangent squared theta, right? Let's see here. Plus 1 is equal to cosecant squared of theta. Okay, that's another thing that I know. Hey, look, I know what cotangent is. I know how to add 1. So cotangent is negative 3/4 squared plus a 1. I'm going to change 1 into be 4/4. This is not 4/4. 16/16. You're going, what? What? Why 16/16? I'll show you in a second. Don't worry. Is equal to cosecant squared theta. Negative 3/4 squared is the same thing as 9/16 plus a, that's where the 16/16 is going to come in handy, is equal to cosecant squared theta. When we're adding up fractions, 9 plus 16 is 25. 25/16 is equal to cosecant squared theta. Again, I'm not looking for cosecant squared, I'm looking for cosecant. Oh, that's handy. And so then I take the square root. Well, the square root is, again, plus or minus 25 over 16. No, 25 over 16. Square root of 25 is 5. Square root of 16 is 4. Is equal to cosecant of theta. So now the question is it positive or is it negative? Well, remember, again, my reciprocal identity says that cosecant is 1 over sine of theta. And remember that conversation we just had earlier? Sine has got to be positive, so that means that cosecant's got to be positive. So that means it is just the positive version of 5/4. And there's my answer. All done. Woo! Again, a lot. Okay. Let's see what's next. We're going to do one more, I think. So here we have different called cofunction identities. These are mainly just shifting, knowing that sine, if I have pi over 2 and I subtract a theta, is a shift. Same thing with cosine. All right, they described how the shift happens in tangent and cotangent, secant and cosecant. All right, fairly straightforward and easy. The next one is the other type of identities. Again, we have these all on our sheet, are called odd/even identities. It's the idea that, hey, sine is an odd function, so when I put in a negative value for x, I should get a negative of my function. Okay? And cosine is an even part of my function. So that means that when I put in a negative theta, I get the same positiveness back. Okay? We'll see how these help us out. Okay? Let's find out how that helps us out. Next. They say if cosine of x is equal to negative 0.75, find sine of x minus pi. Well, if I take a look at my my cofunction identities, I see that this is really close. What they tell me in my cofunction identities is that cosine of theta is equal to sine of pi over 2 minus x. Well, that's very close to what I have there, except that they're flipped. Well, if they're flipped, here's that next math trick I can tell you about. I can tell you that this is equal to, well, sine of a negative. If I factor a negative out of there, pi over 2 becomes positive, and the x becomes negative. And then if I take a look up in my odd or even identities, I see that sine of a negative theta is equal to negative sine theta. So I can take this negative that's here, the negative that's here, and put it on the outside, because that's a property of sine being an odd function. So now I can say this is equal to a negative sine of pi over 2 minus x. Now they match. This matches with this, and I can just substitute in. Say this is equal to a negative cosine of x, which they already told me is negative 0.75. So this is equal to a negative 0.75, which is equal to a positive 0.75. That's my answer. It's kind of cool, actually. You're given one little piece of information, and you're asked to find something that looks completely and utterly different. And really, it ended up just being the opposite of it. How cool is that, right? All right. So here's what I want you to do. This is yours. I want you to be able to answer the question. So time to pause me. All right. Pause me. Hey, boom. There's your answer. All right. So it's basically, hey, it's the same type of information they just gave us on the previous example. So without going through all the work all over again, I know that this whole thing is going to equal to a negative cosine of x. So I take the 0.73, make it negative. It's negative 0.73. All right. Let's find out We're going to do one more, and we're going to call it a day. So now we're going to put everything kind of together. And they want us to start simplifying these. And so one of our rules for simplification is that you know, we want to basically get rid of the fractions if at all possible, and we only want us to only use sine and cosine. Well, great. How can I simplify this? You know, with fractions, you guys were given an idea of how to simplify. You know, take out a common thing. This is kind of like, I need to find some missing pieces. So you're going to use your identities that you have, and you're going to find out, hey, where is there a 1 and a sine squared in there? A 1 and a sine squared. And what you should find is that there is a, you know, in our Pythagorean identities, is cosine squared theta plus sine squared theta is equal to 1. You're going, but wait, mister, I mean, that's not really related. Well, you can do some algebra, right? I can go ahead and say, well, you know what? Hey, subtract sine squared from both sides, and now I have 1 minus sine squared theta. And this is what this is one of those tricks. Now I have 1 minus sine squared theta, 1 minus sine squared theta, and replace it with cosine squared theta. So now this is now 1 over cosine of x times cosine squared x. And this is one of the tricks you got to pick up after seeing it many times. You're going to see, hey, if I've got 1 minus sine squared theta, that's a key to me. That's probably cosine squared. Something that you're going to pick up after you're seeing it many times. So now I come over here and I simplify. 1 over cosine, so this becomes cosine squared x over cosine of x. This is like saying x squared over x. So I get to take out one of the cosines here, take out all of that. I'm left with cosine of x. And what's really amazingly cool about all this is that if I were to go back in and put this on a graph, you would see that they're exactly the same. In fact, here it is graphically. Here's the y equals cosine x graph, and here's all this junk. Wow, exactly the same. Again, mind-blowing, right? It's something that looks like this ends up being just that. Completely amazing. So that's where we're going to end it today. I got 7 more examples that we got to do for tomorrow. Or I might even get the video done and you can watch both videos. We'll see you guys in a couple of days. Bye.